Hello everyone. We have already discussed about foundation, types of foundation and their uses, function of foundation, bearing capacity of soil in previous lecture. So in today's lecture we are going to discuss some different technical terms based on the bearing capacity of soil. So let us discuss one by one. First one is the gross pressure intensity. Notation is small q. It is the intensity of pressure at the base of foundation due to load from superstructure, self weight of foundation and overburden, if any. So this is known as gross pressure intensity Q. Its unit is kilonewton per meter square or Newton per meter square. Next is net pressure intensity. Notation is Qn. It is gross pressure intensity minus the overburden pressure at the level of base of foundation prior to excavation. And mathematically we can write like this: Qn equal to Q minus gamma into D, where gamma equal to effective unit weight of foundation soil, D equal to depth of foundation. Its unit also same, kilonewton per meter square or Newton per meter square. Next is the ultimate bearing capacity. It is the minimum gross pressure intensity at which the soil at the base of foundation fails by shear. This is the ultimate bearing capacity. Notation is QF. Next is the net ultimate bearing capacity. Notation is QNF. So it is the capacity, or it is the minimum net pressure intensity at which the soil at the base of foundation fails by shear. It is the net pressure intensity, it is the gross pressure intensity at which soil fails, but net pressure intensity, the soil fails at minimum net pressure intensity. So mathematically QNF equal to QF minus gamma into D. Next is the net safe bearing capacity. Net safe bearing capacity, this is QNS, is the maximum net pressure intensity to which the soil at the base of foundation can be subjected without risk of soil failure. So mathematically we can write it like QNS equal to QNF by factor of safety, where FOS equal to factor of safety against shear failure. Next is the safe bearing capacity. It is the maximum gross pressure intensity to which the soil at the base of foundation can be subjected without risk of shear failure. So QS equal to, we can calculate QNS plus gamma into D. This is the formula, you can apply this formula, or QS equal to QF by factor of safety, or QS equal to QNF by factor of safety plus gamma into D. So you have to remember all the formula which we can use for calculating or solving the different problems. The last one is the allowable bearing capacity, QA. It is the maximum gross pressure intensity to which the soil at the base of foundation can be subjected without risk of shear failure and excessive settlement detrimental to the structure. So QA mathematically, QA equal to QNA plus gamma into D, where QNA equal to net allowable bearing pressure. So these are some definitions you have to remember. Next is the depth of foundation by using Rankine's formula. So let us see how we can calculate the depth of foundation. So by using Rankine's analysis, D minimum equal to Q by gamma within bracket 1 minus sin phi by 1 plus sin phi whole square, like this, where phi equal to angle of internal friction or angle of shearing resistance or angle of repose. So let us solve a problem. By using Rankine's formula, find the minimum depth of foundation of a square footing in 1.2 meter into 1.2 meter of a column carrying load of 160 kilonewton inclusive of its own weight. The foundation consists of cohesion-less soil. Unit weight is 19.5 kilonewton per meter cube with angle of shear is 35 degree. So this is our question. Let us find out the given data. Here area equal to 1.2 meter into 1.2 meter, load P equal to 160 kilonewton, unit weight gamma equal to 19.5 kilonewton per meter cube, phi equal to 35 degree. We have to find out D minimum. So already we know d minimum equal to, by Rankine's theory, q by gamma into 1 minus sin phi by 1 plus sin phi whole square, where gamma value is given to us, phi value also given to us, but q is not given. So we have to find out the q value. In case of load, we know q equal to P by A. This is the bearing capacity q by P by A. To calculate P, we can apply this formula to find out q, P by A. So let us find out q equal load per area. So 160 by 1.2 into 1.2, this is equal to 111.111 kilonewton per meter square. So finally we put these values here. D minimum equal to 111.111 divided by 19.5 within bracket 1 minus sin 35 degree divided by 1 plus sin 35 degree whole square. So our answer is 0.4184 meter. So this is our minimum depth of the foundation. Next is the assumptions in Terzaghis theory for bearing capacity of soil. It is a short note type question for you in exam. So remember all the assumptions. The soil mass is homogeneous and isotropic, and the soil mass is semi-infinite, that is, it extends infinitely below a level surface, and the footing is laid at a shallow depth, that is D less than B, that means depth is less than breadth. The footing is continuous with length by breadth ratio greater than 10. The base of the footing is rough. The failure surface does not extend above the base of the footing, that is, the shear strength of the soil above the base of the footing is neglected. The next is that the effect of soil above the base of the footing is considered in the form of surcharge gamma d acting at the level of the base of the footing. Next is the load on the footing is vertical and its line of action coincides with the centroid of the footing. Next, the shear strength of the soil is governed by Coulomb's equation, and the principle of superposition is valid here. So these are some assumptions made by Terzaghis to find out the bearing capacity of soil. Next, let us discuss Terzaghis equation. According to Terzaghis, the ultimate bearing capacity of soil is given by QF. Notation is QF equal to CNCSC plus sigma bar into NQ plus 0.5 gamma B N gamma S gamma. This is the actual formula you have to remember. Whenever it is given in the exam or in question that you have to solve a problem by applying Terzaghis, you have to put this formula. Or implies QF equal to CNCSC plus in place of sigma bar we replace it by gamma D into NQ plus 0.5 gamma B N gamma S gamma. So this is the formula. This formula you have to remember. Where C equal to cohesion, NC, NQ, N gamma equal to bearing capacity factor, SC equal to shape factor with cohesion, S gamma equal to shape factor with base, B equal to width of footing or diameter of circular footing, D equal to depth of footing, gamma equal to unit weight of soil. So, value of SC and S gamma, that means shape factor value for different types of footing, like SC, S gamma, types of footing like strip, round or circular, square or rectangular. So for strip footing, SC value is 1.0, for round or circular 1.3, for square 1.3, for rectangular 1 plus 0.3 B by L. Similarly, S gamma value for strip footing 1.0, round or circular 0.6, square 0.8, and for rectangular 1 minus 0.3 B by L. So these are the values of shape factor. According to shape, we have to put these values. So first we consider for general shear failure. It is given whenever phi greater equal to 30 degree, but actually we consider it whenever phi greater equal to 30 degree, 30 degree. From 30 degree and above, we consider it like general shear failure. So under general shear failure, in next lecture or in next slide we will discuss detail about the general shear failure theoretically. So let us discuss the formulas only. So under general shear failure, that means whenever phi greater equal to 30 degree, actually it may be 32, it may be 36, you have to consider it general shear failure. So first for strip footing, so QF equal to, this is the actual formula, C and C SC plus gamma D N Q plus 0.5 gamma B N gamma S gamma. So we know the SC and S gamma value, already discussed in previous slide. First strip footing, so we put the value of SCS gamma. After putting, we found QF equal to CNC gamma DNQ plus 0.5 gamma B N gamma. Similarly for round or circular footing, this is the actual formula. After putting SCS gamma value, we found 1.3 CNC plus gamma DNQ plus 0.3 gamma B N gamma. So you have to remember these formulas, or you can also remember the SCSQ S gamma value. But whenever it is given, that means if it is given in exam that strip footing or circular footing or square footing, then you have to apply the formula according to this SCS gamma S value. Next is the for square footing, QF equal to, this is the actual formula. By putting this SCS gamma value, which we found the formula like QF equal to 1.3 CNC plus gamma DNQ plus 0.4 gamma B N gamma. And last one for rectangular footing, QF equal to 1 plus 0.3 B by L CNC plus gamma DNQ plus 1 minus 0.3 B by L 0.5 into gamma into B after putting SC and S gamma value. Then for local shear failure, whenever phi less equal to 28 degree, in that particular case we consider it as a local shear failure. So to find ultimate bearing capacity of soil, QF equal to 2 by 3 CNC dash plus gamma DNQ dash plus 0.5 gamma B N gamma dash. This is the formula you have to apply whenever it is given in question local shear failure, or it may be given like phi less equal to 28 degree. So for this lecture this much. In next lecture we will solve some problem based on these formulas. Thank you.